Good morning, everybody. Today we are going to continue with graphing, and as you can see here, graphing transformations. All right, so we are going to take the basic shapes that we discussed yesterday. So there was 9 of them yesterday. All right, and we are going to do slides and flips with them. Okay, and for today on this worksheet, there is no exponential or log since we just spent a whole bunch of time doing those. I didn't put any of those on here for extra practice. Okay, on the review sheet, there might be some on there because you could see one of those on your next quiz. All right, so keep obviously how to graph an exponential and a log in mind, but there's none on this particular worksheet. Okay, so this worksheet is actually, you can use this as our notes, but I'm also these are the problems that we don't do will end up being some of your homework problems. Okay, so what we're going to do here is we're going to go over 6 of the 9. We're not going to go over a constant function. I'm not going to tell you, but you should know how to graph this. If you don't, look back at the notes of a basic shape. All right, so we're going to do lines, quadratics, which we've done before. So line and quadratic should be review. Cubes and radicals might be a little new. Absolute value will be review. And rational will be a little bit new because it's just we've done harder rationals. So these are actually much easier than we did before earlier in the year. Okay, so just to review, first of all, you need to be able to look at these functions and know what kind it is. Okay, so you should immediately look at this and know that this is a line. This is a linear function. All right, because the x has an highest exponent is 1. That's it. Okay, now the easiest way, if it's in this form, all right, good old back to like 7th grade or 8th grade or wherever you guys learned this, y equals mx plus b. All right, little slope intercept form. So -2 would be our slope. 3 is our b, which is our y-intercept. All right, so we just graph our y-intercept. All right, so we graph our y-intercept, which is at 3 on the y-axis. All right, we then do slope. So what I want is 2 points. So you have 2 options. So -2 means down, it's -2 over 1. So it's down 2 to the right 1, or you could have gone up 2 to the left 1. All right, and there is your graph. And for good measure, just label the points 0, 3, and 1, 1. All right. The domain and range of this are both -infinity to infinity, and all lines will be that. All right. So in case you forgot how to graph a line, that's a line. All right. So next one we're going to go over is number 4. All right. Now, 4 you should look at, and what type of function is this? Well, by looking at the 2, it's a quadratic. All right. In the exponent, you see you have a squared. So this is a quadratic function. Just like number 3 is a quadratic function, 4 is a quadratic function. Okay. Now we should know that the basic shape of this is a parabola. Now we spent the entire, almost feels like first semester doing quadratics. Okay. Now, if you remember, we did like y equals like a, it was like x plus h squared plus k. You guys remember this? This is like vertex form. All right. And if you remember, this in here, if we set this equal to 0, this helped us find our x coordinate vertex. This number right here was your y coordinate vertex. All right. Now let's think about this. The normal basic shape is 0, 0 for a parabola, right? It's at 0, 0. Well, what you're really doing is, if you think of like slides, you set whatever the parentheses with x equal to 0, that makes it slide to the right or to the left, which is going to give your x coordinate. This k is going to move it up or down, which is going to give you your y coordinate. All right, so what we're doing is you're moving the vertex 0, 0 to the right and to the left and up and down. All right, so before we just thought about, oh, that's the vertex. Well, the reason it's the vertex is because we are sliding from 0, 0 in that direction. Okay, so if we look at this problem, there is nothing in there. You know, our normal vertex is at 0, 0. If we think about it in terms of slides, 0, 0, the x doesn't move. There's nothing in there with the x. So it's at 0. We don't move it left or right. It stays there. We just move up 1. All right. So let me just do this real quick. All right. So our vertex is at 0, 1. Okay. Now you can just look at this and know remember vertex form. Great. 0, 1. You put that there. If you don't remember vertex form, fine. You should still know now with our transformations, our slides, nothing in parentheses with x. X doesn't move. 1, you just move it up 1. There's our vertex. Now, what does this 2 do? What does the A do? That's how much you move up or down, and we always put it over 1. We always go to the right and left 1. Always the right and left 1. So in this case, since it's positive, we're going to go up 2 to the right 1. And our graph just looks like that. All right, we're at, what was that, 1, 3. All right, 1, -1, 3, and 0, 1. All right. Now, if there was a negative in here, normally that means like a vertical flip. But what would that have meant in terms of parabola? We would have gone down 2 to the right, left 1. What would happen? The graph would have been facing down. It would have flipped. All right. So these are all the things that, before when you thought about a quadratic, you weren't thinking about flips or slides, but we were essentially doing that from the beginning with quadratics. All right. Now for our domain is -infinity to infinity. And our range is going to be whatever the vertex is. If it's going up like this, where's the vertex at? It's at 1 with a bracket, because it's allowed to be 1, to infinity. If you have it facing down, it's going to be -infinity to whatever the y-coordinate of the vertex is. All right. So now let's move along. Got some more practice here with quadratics. All right, let's do number 7. All right, number 7. Now, number 7 is what type of function? Well, it is a cubic function. How do I know it's a cubic function? Well, because you have this cube up here, right? Remember, a cube is an S-curve, all right? It is an S-curve, and it's at 0, 0. This point is 1, 1. This point is -1, -1, okay? So the first point that we always want to graph is this middle point here, all right? That middle point. That's what we want to graph first, okay? So when you have a cubic, it's normally 0, 0. You want to move that first. And the way you're going to graph that is by looking at any slides or any numbers like here, almost like you just graphed the vertex of a parabola, all right? So, so you're just sliding 0, 0 on first. That's the point that you're worried about, okay? Let me just slide this up a little bit, sorry. All right, so since we have this, that means you set that equal to 0. We're moving this 1 to the right. So from 0, 0, we're going to slide that over, all right? And it's going to be at 1, 0. Why do I not move it up or down? Because there's nothing over here. If there was a +1, I would have then moved that up 1, all right? But there is not, so we don't have to worry about that, okay? Now, to get your other 2 points, and you need 2 other points, even though it says label 2 points in directions, with a cubic, I want you to label 2 others, one to the right and one to the left, right? One to the right, one to the left. All right, so now the way you get your other 2 points, okay? Normally, see how the graph looks like this? All right, no, this is your X and Y axis. It goes like that. This negative right here is going to be a vertical flip, which means the y coordinates change, right? So we flip over the x-axis. So basically, you're going to have something that looks like that, all right? So anytime you have a flip, that's what's going to end up happening with that, okay? Here's the thing. Guess what a horizontal flip is? If we did a horizontal flip over the y-axis, guess what? You get the same thing. So if there's a flip, kind of like you have number 8, we're going to have a negative there, all right? It's going to be the other way. It's not going to go up from left to right. It's going to be going down from left to right if you have a negative in either spot, okay? If you have negative in both spots, it ends up exactly where you started, okay? Now, what you're going to do is look at this number. That is going to tell you how much you're going up and down, all right? The negative just tells you that when you go up, I'm going to go to the left. When I go down, I'm going to go to the right, okay? So normally it's y equals x cubed. That's a 1, right? The basic shape y equals x cubed. There's a 1 there. So from 0, 0, you go up 1 to the right 1, which is at 1, 1. You go down 1 to the left 1. That's where you get the negative 1 from. So here I'm going to go up 2. And the reason I'm going to the left is because it's a negative. I go down 2 to the right 1. It's almost like when you're doing negative slope. All right. And then you just have to, graph your S curve. All right, something along those lines. As long as it's, somewhat a nice little S curve. It's not the best drawing on this using the mouse, but you guys get the idea. All right, that is a cubic function. It should have that roughly. If it's going that way, something that looks like that. If it's going the other way. All right, now the domain and range of a cubic are always going to be negative infinity to infinity for both. All right. So to review, for a cubic function, you want to graph this middle point first. And you do that by moving from 0, 0, whatever. Here moves it left and right. Anything here moves it up and down. Once you get there, you use the number in front of the parentheses to go up or down. You're always going to the right and left one. Always to the right and left one, just like you're doing with the parabola. But you're going up and down. All right. If it's negative, you go up to the left, down to the right. If it's positive, you go up to the right, down to the left. All right. Just label these points. This is 0, 2. This is 1, 0. And this is, what is that? 2, negative 2. All right. So now, you can see there's another practice you can do with the cube. All right. So now let's go down to one like number 9. All right. So number 9, what type of function is this? All right. This we have a radical, or in particular, this is a square root. All right, this is a square root function. Okay, I'm not going to give you any cube roots. We're going to be doing just square roots. Okay, now if you remember, the basic shape of a square root is this, with 0, 0. That's where it originates from. And that's what we're going to call our starting point. All right. I'll put SP. All right. That's our starting point. All right. So our starting point is normally at 0, 0. All right. It's normally at 0, 0. For this problem, guess how we're going to get our starting point? Well, what does this mean right now? What is that doing to our problem? All right. Well, this is moving it 4 to the right. All right, this is 4 to the right because you set that equal to 0. There's nothing over here, which means we're not moving it up or down. This moves it up or down, right? If you look at this next example, this would move it down 1 and so forth, okay? So that means our new starting point is not at 0, 0. It's going to be at 4, 0. 1, 2, 3, 4. All right, that's our new point starting point is at 4, 0. Now, normally, our basic shape here goes that way. But we have a negative, right? A negative in front of the x. That means that it's a horizontal flip. It means I have to flip over the y-axis, which means it's no longer going to go to the right. It's now going to point to the left. So if you have a negative in front of the x, it's not going to point to the right anymore. If it's positive, it points to the right. If it's negative, it points to the left. If it's negative out in front, it's going to point down. All right. So when I say like point up and to the right, down and to the right, up to the left, down and left. So it's either going to look like this, like that, or like that. All right. Those are the different ways a radical graph can look like. Now you just need to graph one other point. So my graph is going to look something like that, but what's my other point going to be? All right. To get that point, you're going to do what we've kind of been doing for the last couple of graphs, which is to look in front of the the radical sign. Okay, it's 1. Okay, this other point is 1, 1 on a basic shape. All right, and the reason is because there's nothing in front. Whatever's in front there, that tells you how much you're going to go up or down. Since it's positive, I'm going to go up 1. You're always going to go to the right or left 1. I'm not going to go to the right 1. Why do I know I have to go to the left? Because I know this negative, this graph has to point to the left. So there's my point right there. All right, which is at 3, 1 and 4, 0. All right. So once again, I've got the starting point by doing just like you're shifting right and left. Set this equal to 0. That's at 4. There's nothing there. So this is at 4, 0. Okay. Then I look in front of the square root. All right. That's a 1. So I'm going to go, it's positive. So I go up 1. If it was negative, I'll go down 1. The reason I go to the left is because of that negative. You're always going either to the left or right 1. In 10, whatever my starting point was at, I would go down 3 from there. And I would go to the right 1 because it's a positive x. All right. This graph should be pointing down and to the right. All right. You guys can try that one for homework. All right. So the important thing with the radical is your starting point and then getting your second point by using whatever's in front. So a lot of these graphs are done very, 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 very similarly. All right. All right. Now, to number 12, absolute value. An absolute value is done identical to the quadratic, okay? The basic shape is this. It's a V, all right? It's done the exact same way as a quadratic. You can almost think of it as a quadratic. You can just use like the vertex form, all right? This is your vertex, all right? But you can just think of it in terms of this is 0, 0. How do I move this vertex? Well, I'm going to move the vertex to the right 2 and down 2, right? Set this equal to 0. That moves it down 2. Or you can look at it as that has to be the vertex just because the way it was for a parabola. To the right 2, down 2. All right. So to graph, 2, 2 is my vertex. All right. Now, what's in front of the absolute value? Nothing, which is a 1, which means I'm going to go up 1 to the right 1, up 1 to the left 1, and I draw a V. So it's just like a parabola, except you draw a V instead of a U. All right, those points 2, 2, 3, 3, and 1, 3. All right, the domain is negative infinity to infinity. The range is where the vertex is above, so it's from 2 to infinity. All right, I forgot to do the domain range shockingly. I forgot to do it over here. All right, the domain, well, all right, you have restrictions on both of these. So the domain is from, it's pointing to the left, so it's going to be from negative infinity to where does it stop? What's the x coordinate here? 4, right? It's equal to it, so we got a bracket. Now, for the range, there's nothing down here. What's the smallest spot? It's 0, right? And where does that go to? Infinity. Even though it looks like it's not, it is still gradually going up. All right, very slowly, but I promise you it's still going up. All right, so let's see. There's one more we want to do on here, which is a rational, okay? I lied. There is an exponential on here. There's one over there, number 20. And there is a couple logs. So I lied to you. There's a couple logs and exponentials just, but I'm not going to go over those because we spent so much time doing those over the last week or so. All right, so rational. All right, so 14. All right, we have a rational, which means a fraction. Okay. All right. Now, basic shape of 1 over x. All right, 1 over x was we had curves here and there. All right, and we had a vertical asymptote at 0. We had a horizontal asymptote at 0. Now, if you remember from rationals, if we set the denominator equal to 0, that gives us our vertical asymptote. Okay, well, which is -1, which also makes sense because once again, we set this equal to 0. It's -1. We have a shift of everything to the left 1. So this is our basic shape. Of course, our vertical asymptote has to move to the left 1. All right. So we have a vertical asymptote at -1. Okay. We normally have a horizontal asymptote of 0. There's no number over here, which means we're not moving anything up or down. All right, nothing is going to move up or down, which means the horizontal asymptote is going to stay at 0. If there was a plus 2 here, the horizontal asymptote would be at 2. So this down here is going to give you your vertical asymptote. The number over here is going to give you your horizontal, but there's nothing there, so that's why it stays at 0. Okay. Now, where your curve is going to be, okay, what you're going to do is use the number on top. Okay, our points here were 1, 1, and -1, -1, because that was a 1. All right. Now, what this basically means is the same as 2 times 1 over x plus 1. Okay. The basic shape is 1 over x. It gets moved 1 to the left. Right? This out here, what we're basically doing is a vertical stretch. We're stretching this. Okay. And that's what all those numbers out in front of, like the quadratics, the cubes, the absolute values, the radicals, they're just stretching it from your basic going up and over 1. All right. They just add a little something to it. All right. But all you have to realize is whatever this number is, it's like the number out in front of your quadratic. It's how much you're going to go up or down. All right. So normally they're here. There is no negative in front of the x, which means it would be a horizontal flip. The curves would be here and here. There's no negative out in front, which would also do the same thing to the curves. There's nothing. So our curves are still going to be in this quadrant and that quadrant. They're just not going to, everything just got shifted to the left one. So the easiest thing to do is you find this middle point. It's where the asymptotes intersect, which is at -1, 0. And I am going to go up and down 2. Okay. So I'm going to go from here. I'm going to go up 2 to the right 1, always to the right and left 1. And my curve is there. And that curve is at 0, 2. All right. All right. Then you can go 1, down 1, 2 to the left 1. All right. And that is at -2, -2. All right. All right. So there, and you probably should label the asymptotes too. So x equals -1 and y equals 0. All right. So get your asymptotes. You know from your middle point. This is how much you go. If this was a -2, you would still go up and down 2, but you would go to the left 1 and to the right 1, and your curves would be there. All right. So you got to be careful with your domain and your range here. Your domain is -infinity to whatever your vertical asymptote, which in this case is -1, union -1 into infinity. Then the range is the same thing, but to your horizontal asymptote, which is -infinity to 0, union 0 to infinity. All right. All right. Hey guys, I don't know what just happened. It paused. Hopefully you saw me finish the last one. In case you didn't, it was at -1. This was at 0. I take this. I go up 2 to the right 1. I go down 2 to the left 1. I make my curves there and there. The domain was from -infinity to -1, union -1 to infinity, right? -infinity to -1, union -1 to infinity, and the range was from -infinity to 0, union 0 to infinity. All right, so it's whatever. This is always the same. It's whatever the vertical asymptote is. This is whatever the horizontal asymptote is. So sorry if I hit pause for a second and I thought I hit play, but I don't know what you got. I looked back. I talked a bunch and it wasn't there. Okay. So what I was just saying to nobody, because it wasn't recording, is for homework, what I want you to do is do one of each type. So there's 9 types. All right. I want you to do one of each type. You don't have to do all 18 of these. Just do one that are remaining. There's 24 problems on here. We went over 6 of them, so there's 18 left. Just do one of each type. So that's a constant function, a line, a quadratic, a cubic, a radical, or a square root, I should say, an absolute value, a rational, an exponential, and a log. All right, so do any 9 you want. If you want to do more for extra practice, you can, but you do not need to do all of them. All right. Um, we will be reviewing this again next week, and then we'll have a little quiz on just the basic shape transfer, graphing these basic shapes next week sometime. All right. Hope all is well. Let me know if you have any questions. Thanks.